All right. Hi, everyone. My name is Kate Sills. I'm a software engineer and independent consultant, and I previously worked with Mark Miller at Agoric and built their smart contract framework, Zoe. And today I'm going to be talking about new frontiers unlocked by cryptography. So something that I've been thinking about for a number of years now is, what are blockchains actually good for, right? So there's a lot of hype in the industry. There's maybe some use cases that are really overvalued, but I think there are some use cases that are really undervalued. And so that's what I'm going to be talking about today. And so my hypothesis, let me get rid of this. This is very hard. Okay. All right. So my hypothesis is that there are important use cases that are being overlooked and undervalued because they don't involve tokens, and everyone's focus is on tokens, right? So I'm going to do a deep dive into one of these use cases, and it's going to be a little bit strange. It's going to involve cantaloupe, so bear with me. Oh, now we're still in Zoom. Okay, so for the use case, let's imagine that we're a fruit processing company, and our use case is that we want to make sure that our company logs are not being faked. So this is extremely important. It might not seem very important if you're kind of outside the industry, but there are certain things that you have to check all the time if you're, a processing company. So for instance, you might want to check that your cantaloupe are being refrigerated below 41 degrees Fahrenheit in order to prevent listeria. And listeria can be very deadly. There was a huge outbreak in 2011 where 30 people died. And so this is something that we really want to check. We want to make sure that, our employee isn't just filling in the data at the end of the week and not actually checking, or, just writing down big information, right? So we really want to make sure that we have these desired properties, that the logs are timestamped and that they can't be backdated. We want to make sure that the information can't be altered after the fact. If anything is tampered with, we want that to be evident. And we still want it to be private, right? So we don't want our competitors to know how much fruit we're processing, or, what have you. Okay, so the kind of naive solution that we might have is, let's just put it on Bitcoin, right? So let's take that log that, says that the temperature was this temperature, and let's hash that entry. Let's create a Bitcoin transaction, and let's just put the hash in the op return field, right? Easy peasy. Well, that's really expensive. I think it's something like $1 per Bitcoin transaction or something like that right now, last I checked. It doesn't really scale. The Bitcoin community doesn't really like it, because you're using something that they're using to transact with, and you're just dumping data in there that they're going to have to keep in their full nodes. And, it has negative externalities. You're forcing them to keep that data. And so can we do better? And I think we can. So for the purposes of this talk, I'm going to be using what I call a Jenga approach. So what I'm going to be doing is identifying components. I'm going to be taking them out pretty drastically, and then I'm going to see what actually fails. And if nothing important actually fails, if we're not losing any important properties, maybe we can just leave it out, right? Okay, so let's start big. Let's take out all of the tokens, right? So can we just take out all of the cryptocurrencies and see what happens? So let's start with something like Bitcoin. And if we take out the tokens, well, then of course, we don't have anything like UTXOs. We're not tracking whether anything has been spent or unspent. If we were working with something that used account balances, we wouldn't have those either. And trivially, we've solved the double spending problem, right? Because there's nothing to spend. And one thing that's interesting is that there's no in-system compensation. So if we needed that for some kind of purpose, we're not going to have that. So we can still have external compensation, like we might be able to pay with other cryptocurrencies that are on a different chain, or we might be able to pay with credit cards, but we don't have in-system compensation. Okay, let's go further. Let's take out all of the state. So by state, I mean things that are manipulated with transactions, right? So can we just take all of that out? Well, for our purposes, if we're just trying to make sure that logs, the entries aren't being tampered with, can we just add that data to the transaction log, right? And not actually have anything that's being manipulated. So I think if you do that, there's some interesting effects. So first, it basically means that we don't have smart contracts, because smart contracts are all about manipulating state, right? Like transitioning from one state to another. And if we're not doing that, then we don't really have smart contracts. We also don't really have a semantic understanding of the data. Really, we're just dumping things in the transaction log. And then there's another few interesting effects. Transactions don't actually affect each other to the same extent, right? Like if one transaction happens first, it's not going to invalidate the next because there's no semantic understanding of what that means. We're just dumping things in the transaction log. And then I think this is the most interesting part, is that censorship or liveness issues, like if we can't add a new transaction, there's nothing that's locked in because we're just adding things to the blockchain. There's no state that's being manipulated. So like with Bitcoin, if I can't add a new transaction, I can't spend, right? But if there's no state and there's no tokens, there's nothing necessarily that's locked. So potentially exit costs are a lot lower. Okay, let's keep taking things out. So let's take out, the anyone can write. So, if you're doing a cryptocurrency, it's really important that there's not a centralized entity that can be minting things or adding transactions, right? For our purposes, let's just say that it's a permission set of entities that can write. And so that means that we don't need proof of stake, we don't need proof of work, we don't need any kind of symbol proof mechanisms, right? And proof of stake was already eliminated anyways because we took out tokens earlier. Okay, so let's just recap what we have so far. So we have a blockchain with transactions that just depends to a log. We have a permission set of writers. Anyone can read though. Let's make sure that that's still public. So anyone could be running a full node. And let's say it's incentivized by something, maybe out of system payments. And there's no tokens and no stake. Okay, let's go even further. Can we take out a Byzantine fault tolerance? And so by a Byzantine fault, I mean faults beyond just crash fault. So instead of something going wrong and it's just like, nope, that node is down, the node could be lying or just violating the protocol arbitrarily. And so let's divide this up into two different kinds of faults. So let's say liveness. So that's something that would prevent us from adding more things to the blockchain. And then safety, where, people might actually see different versions of the blockchain if safety is violated. There might be forks. Okay, here we might have gone a little bit too far. So, a node could shut down entirely. A node could refuse transactions and maybe selectively, like, oh, I don't want to deal with your transactions. I'm not going to put them on the blockchain. We could have our blockchain fork, which wouldn't be good for our purposes, right? Of wanting to make sure that the business data isn't being tampered with. And the nodes could just be doing things wrong. They could be hashing things wrong. Maybe there's no actual correct chain because their hash pointers are just not being done correctly, right? So there's a lot of things wrong that could happen here. So I think there's some ways that we can add more things in to actually fix this. So to fix forks, we can commit the head of the blockchain on a regular basis to something that we don't control, like another blockchain or a public newspaper, something like that. To fix the crash faults, we can select another leader to continue, and that's basically kind of like the Raft protocol. And then to fix errors, we can ensure that the chain is publicly readable or verifiable. So if people actually are running full nodes and anything wrong happens, they'll be able to at least identify it. And so this is something that I'm still working on and still thinking about. So I'm really curious about your thoughts. But if we don't actually have state, if we're not working for the purposes of something like cryptocurrency, then what does fault tolerance mean in that case? And so if we're just looking for a service, I think a better analogy might be like trying to eat out at a restaurant, right? Any particular restaurant isn't fault tolerant. Restaurants fail all the time, but I can pretty much guarantee I can go out to eat someplace in San Francisco tonight, right? And so if there's nothing locked up and the exit costs are really low, can we deal with faults by simply finding another service, right? So that's something that I would love to think more about. And as far as I can tell, the computer literature doesn't really combine the computer science and the economics of different services. Okay, so what do we end up with? Well, we have our permission set of nodes, which can add transactions, and perhaps they're all part of the same company or service. Anyone can read and verify that a particular hash is included. The presence of the hash embedded in a blockchain means that the log is timestamped, at least according to relative time. And any tampering with the log after the fact is something that is evident. The log is still private, and the costs are pretty low. There's no need for proof of work, no need for proof of stake. There's no need for replicated smart contract execution because that's not our purpose here. And in terms of compensation, users could be required to pay the service in order to add transactions. And if the service is bad, maybe we can just use a different service. So it's not a coincidence that this actually looks a lot like the original blockchain. So the Bitcoin paper references this paper by Haber and Sternetta from 1991, which is about a timestamping service. So they were using hash pointers to make sure that documents could be timestamped and that there would be proof that this document existed at this point in time and wasn't tampered with after the fact or wasn't backdated. So there's this really incredible paper called Bitcoin's Academic Pedigree that makes the point that most of the ideas in Bitcoin that have generated so much excitement were already existing, and Bitcoin's Satoshi's innovation was actually putting them together in such a unique way where there were economic incentives involved with computer science. But the other part of this is that for a particular problem, if we're not trying to create electronic cash like Satoshi was, there might be things that we can use that are long forgotten solutions that might have existed 20 years ago. So that's really what I'm most interested in right now is what can we use out of the cryptographic tools that already exist to solve problems that we might have, business problems that maybe the cryptographers aren't focused on. And I think there's a lot there. And I think, you know, the field is huge and there's a lot that we can do. So thank you so much.
Wonderful. Very excitable. I did come together. Okay, question coming in. Yes, I will be doing the mic run.
Hello. So I was thinking that reminds me a bit of like a application roll-up sort of thing. Like you have your application which is designed to interface with the blockchain, and then there's like this other blockchain that's doing flooding stuff. The programmer is kind of riding on that. Is that kind of where am I trying to direction how these ideas connect?
Yeah, I think the ideas are similar. I think I think the idea of who you can trust might be a little bit different. Like, because I think if there's not something, the difference is still whether there's something locked up or not, right? And so like in the case in which there isn't something locked up, like in this case where, you know, we're just appending things to the transaction log, and potentially we could be doing that with multiple different services at once. And if, you know, one of the 5 goes down, it doesn't matter, right? So we kind of have like a meta fault tolerance by composing different services. So I think what I would say is the mechanics might be similar, but I think the trust scenario is actually quite different.
Cool. Question.
So I'm probably misunderstanding, but taking away it seems like almost all of the attributes of the traditional blockchain as I've grown to know them over the past 6, 7, 8 years. Everyone, all the idiots on Twitter are like, that's just a TV. Like, what's the point? The properties of censorship resistance or require some sort of work, or everyone is allowed to have access to the data. Those seem to be removed from what it is you are presenting. I guess I'm wondering, I don't think there's necessarily a good or a bad solution to, or a good or a bad like judgment on the most centralized DB in the world versus the most decentralized blockchain. But I guess I'm wondering, where does this fall on the spectrum of this is more towards a DB versus a blockchain?
Yeah, that's an excellent question. So I think there are a few key components that make this very different than like, just a MongoDB database. And so if everyone can run a full node and there's, people actually have the actual data, then that means that they can compute the head of the blockchain themselves and make sure that all of the data is correct, right? So with MongoDB, right, like if I just had a replicated copy of that, if someone changes something, I'm like, oh, well, that's maybe they're right. I don't know, who knows, right? So that property of being able to recalculate the whole chain and make sure that the hash is the same, I think that's basically the Haber-Sternetta point from 1991, is that like, that's what hash pointers are really cool, right? And then I think having to commit the head of the blockchain somewhere else is also a really essential property to say, like, at a certain point in time, this is what things were. So it's like, it's a finality stamp, basically, that like what has happened in the past, what this chain is at this particular point can be summed up in this one hash, right? So like, but you're right, the censorship resistance is not there, right? So if like, Bitcoin's electronic cash was, I assume, probably designed around having like a nation state adversary, right? And this doesn't have that, right? But what I'm really curious about is whether the service itself is enough of a commodity and exit costs are low enough that you can simply have, millions of these different services or thousands of these different services and be resilient on that meta level. And that's what I'm curious about.
So I think the existing live system is most reminds me of transparency system for logging. Yes, I wish I could off the top of my head how it works to try to compare it with that. It has sort of a bunch of different servers that I think it's like by different parties. I guess you sort of have to notice. I believe anybody's getting copy of the log, but I see not anything from a sort of participating node. I don't have a great sense of how that works. And then of course it's a single purpose system. It's not a general purpose maintained system that anybody can engage in. So it's limited to the sort of have a problem to understand and but I just
Yeah. Yeah, definitely. And if I can ask some further questions about that, I'm not very familiar. For that use case, it's okay that everything is public, right?
Yeah.
Okay. So I think that's really interesting. One reason why I would want to split kind of like the registration and integrity from the data itself is for the use cases where you don't want everything to be public, right? Because it's easy to do things privately if you just keep it to yourself, right? That's the easiest way to make things private rather than going to like CDK knowledge groups.
But kind of as you were already alluding to, you can always just say, okay, well, the public thing is to have some private thing.
Right. Yeah. But that's a really cool use case that I would love to learn more about. Yeah.
Okay, well, I have a few. So I always have my most standard questions that are a little bit perhaps forward or like broader looking, like, if you think this further for the next like 5 to 10 years, if everything goes well in this positive future scenario, where could we end up? Like, what's kind of like the major changes if this wide adoption for like this is one of many of these individual examples? Like, why are you so excited about this? Where could we be in like 10 years? So.
Yeah, that's a great question. So I'm a consultant, and right now I'm working with Starling Lab. They're working on integrity for photos and documents. So you can imagine, like in Ukraine, you're documenting a town that has recently been taken over, that had previously been taken over by the Russians, and now it's taken over, and you're documenting what was there. There's huge disputes globally where Russians will say, oh, everything was faked and it wasn't actually that town, and all sorts of things like that, right? And so I think in the future, especially with deepfake technology getting better and better, and it's going to be extremely important for us to use blockchains for specifically the registration of data and especially images and videos and documents and all sorts of things where we can say like, look, you know, there's a lot of things that I can't prove about this, but I can prove that it existed at this point in time. And, you know, it wasn't just created right before this trial, right? We didn't make this up. And so like, and I think going back to the discussion that we had earlier about kind of the general public understanding some of these things, like, I think there's going to have to be a huge information campaign, not to explain the cryptography, because honestly, no one understands that, but you know, to explain the applications and what you can actually guarantee and not guarantee based on certain things. And so like, I think it's still really hard for people to understand, especially given the token focus, right? Where people are like, oh yeah, you need, like, I need to mint an NFT, right? To be able to track this document or something like that. Or like, I think there's a lot still to go.
Okay, next question, unless someone stops me, right?
That question, but more like way that I said, what's next?
Sure. Sure. So let me preface this by saying that this is my involvement is relatively new. So I've only been working with them for a couple of weeks at this point. But what I'm really excited about is they have a number of different projects going on simultaneously. And the one that I'm working on is basically kind of this question of like, but with potentially the addition of working with photo metadata and working with the photos themselves and having to hash them. But you know, how do we, what's the most efficient way, right, for us to actually first record all of this data in a way that gives us integrity and then source it back to the tools that people use. So I think previously we were talking about a tool where you could annotate newspaper articles. What was the name of that? Public editor, right? Well, there are all kinds of tools that journalists use right now. So like there's Uwazi and Document Cloud and Google something or other, Google journalism something. So how do we actually take, you know, let's say we did actually timestamp this, how do we feed that back into the asset management system so that people who aren't cryptographers can understand like, yes, we know these facts about this, you know, this photo or this document. So that's what I'm really interested in. It's like, it's both a technical and product question, right? But I think that's the coolest aspect of things.
So I wanted to ask a bit more of an advanced question. Jenga style, and I think that was a really nice analogy. Highlighted what you should be doing really learning something taking kind of simplest and not kind of go against the style. But I'm curious about the extent to which we're going to advocate this Jenga style approach whether ideally what you want to be aware of go back to saying and I guess the final point maybe one thing might actually get to how characteristics that they're and you might be able to increase the this sort of person better sense of class.
Yeah, so I definitely think you shouldn't build systems entirely just based on the Jenga methodology, right? Just don't just take things out willy-nilly, right? But I think it's incredibly useful for finding out what each piece does. And that goes to your second point where like, once you find out what all the pieces do, then you can create a, directory of like, hey, do you need this? Maybe use this. But yeah, I think, a lot of times there's so much, I guess like mythology or hype around like, say like Bitcoin, that I think people don't necessarily get what each piece actually does. And so when you start taking things out, then definitely if you put that in production, you would find out pretty quickly what each piece was good for, right? And so I think I like it as an exercise at least. And so that's kind of like how I think about it is being able to break a system down into components allows you to think about what each component is contributing separately.
Roughly a time, but maybe I'll.
So cynically, the thing that came to my mind when we're talking about verifying, hey, did Russia invade and destroy this town? Are these election results verifiable? My sense is that it doesn't matter if the mathematics prove that something is 100% true. If you go to someone who is Vladimir Putin, an apologist, or someone who is on the far right, who believes every election is fraudulent, it doesn't matter how much you could show it to them with their eyes, have them go through everything. There would be zero change, and they would just get stuck in deeper. Do you think that there's a lower level problem to be solved around the psychology of why people behave like that versus like, this is fantastic work. You can do it for things like, what's the temperature of a cantaloupe kept at 40 degrees, but for something with an emotional arc to it, people are just going to dig in deeper, cover their hands or cover their eyes and their ears.
Yeah, my reflexive response to that is saying like, yeah, you've got your, 0.05% or whatever. But like the 80 or 90 or whatever, hopefully percent, which is basically sane normal individuals who want to go about their lives, right? The thing you want to do is give them a place that they can go and say, I know what's actually true and I can ignore all the ones where
Yeah, I think that's true that there are the number of people who are at the extremes is limited. I think also, what we have seen is like, for instance, people saying like, oh, it's the pictures are real, but the people in them are actors, right? So there's or like, going back to the cantaloupe example, it could be that no one actually did the check, but they put in the logs at the correct time, right? So there can always be ways of messing with the data before you actually put it into a system that can guarantee the integrity of the data at that point on, right? And I think, that's what you have to have like human controls for. You have to have processes in place where there's checks and double checks. So yeah, but it's a really hard problem.
Thank you, Kate. That was great.